Today we're going to talk about why zinc is not considered to be a true transition metal. Now, transition metals exist in the D block, and most true transition metals are considered to be multivalent. Okay, so multivalent, more than one charge possible. So, when you look at something like copper, you know, copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So, when copper, this is copper's electron configuration, when copper forms an ion, it can do one of a couple of things. It can lose both of these 4s2s, and it forms Cu plus 2. Okay? Now, the other thing it can do is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Okay, so the other thing it can do is it can lose 1 out of the 4s. And then scoot the other 4s over here, and now you have that really cool 3d orbital all the way filled in. So this is a boot, and then this is what I call the scoot, and you got to watch out for these guys that want to do the scoot. And so you have here only lost 1 electron, whereas up here you've lost 2. Here you've lost 1 and moved 1. So that's Cu plus 1. Now, zinc. Oh, this is multivalent, which means you could either have copper 2 or copper 1. So I'll write that for you just so. Copper 2, copper 1. All right. So that's copper 2 plus 2, copper 1 plus 1. Okay, so this is multivalent, which means that copper, under different conditions, can form 2 ions. Okay? Now, when we're dealing with this in class, you'll either always have a formula to go on or a name. So, for example, CuCl2, that's going to be copper 2 chloride. CuCl, that's going to be copper 1 chloride. Okay, so you see here we'll either have the name written like this, where we would know to write the formula that way, or we would have the formula and we can, do a little forensic work there on the formula by going like this. CuCl, we know that there's 1 chloride, he is -1, and so that would mean since there's 1 copper, it has to be plus 1. Okay, so I know what you're saying. You said you were going to talk about zinc, and you spent the entire time talking about copper. But we needed to understand what multivalent was, so we can see why zinc is not multivalent. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay, so zinc has a full d orbital. So since it has a full d orbital, it only has one move. It can only lose the 4s2 and form a plus 2 ion. There's no movement possibility here in the d orbital because it's already full. And so zinc only forms a plus 2 ion. Sometimes you see it like this, zinc 2, A lot of times they just drop it off because it's the only thing that's happening. The reason why zinc is not a true transition metal is because it's not multivalent. The reason it's not multivalent, full d orbital.